So for this, I've loaded the fuel and boost information profile just to allow the advanced maps to go through that. So now when we select advanced maps, it recognises we've had a profile change, so therefore obviously start of injection is no longer relevant. So we'll build it. I've made no changes to the maps. This is just a straight build. So therefore we've got two options, just to build the tables only or build the tables and compare maps as well. Since there's no changes, there's no point building the compares because there'll be zero changes made. So we'll just go tables only. Obviously the advanced map and advanced map compare pages are destructive. You can do whatever you like to them because they just get rebuilt each time. So you can delete whatever you need to delete, which comes handy when you're trying to build certain maps. You may want to delete certain rows and columns just to make the map match what is over on your map ref page. But as we can see, we've now built it with driver's wish high range with a 0 to 100% throttle input, because that's how we have this set up now. So this is 0 to 100%, where the driver's wish outputs an IQ, and then other things that have IQ input will use that. So it's no longer we're no longer using a calculated IQ. Whatever the IQ is of the driver's wish in response to a 0 to 100% throttle is what the IQ of the other maps will then be inputted with. And that's where you get your slightly more odd shape of some things. Everything has a heat map, minimum to max value, torque limiter as we've seen previously, single axis, along with the graph in row or column depending on how you set it up. Again, we can just basically use these maps. If we don't like it like that, we can change that, and now it's changed to whether the x-axis or y-axis is used as a series or value. You can change the chart type if you like. If you wanted to come over to, sorry, not that one, change the chart type, you can then select whatever the available charts are to bring it up. Now this is where some people might like surface charts. Now that's obviously not a very pretty one. If we went to the SOI, that's where it would show you the nice lumps and bumps, but you can put a 3D chart in here if that's what you'd rather see. But that's all available to change. Again, it's all destructive and you can do what you like. Where it comes handy is if you have a map over here, say you had the boost limiter map and you wanted to know you were hitting boost limiter, as we do on the stock tune, you may want to then take the boost map from the advanced maps, delete particular rows and columns to find out what your actual request is, bring it back to your maps page, sit the output of that beside your boost limiter, and then you can run calculations back and forth to then modify your boost limiter to ensure that it's not limiting you. So that's where this advanced map becomes handy, because like I said, you can just delete columns, you can do whatever, you can be destructive, sorry, wrong one, that should be delete, to then line it up. Now the chart will whinge at you, but that's okay, because obviously you've deleted a series out of the chart. But then you can do whatever you like, delete rows and columns. Change this to look however you need it to look. If you delete the chart, then that'll stop that alert coming up, to then be used back in your maps, to then do your calculations to say, okay, because as we can see, boost request here and boost limiter are different shapes and sizes and different inputs. So all we would do is we would configure this boost request so that it had the same columns as the boost limiter, the same rows as the boost limiter, and then we could just use, if you wanted to use a simplistic method, just use a plus 100 example, and then the boost limiter will always be 100 millibar above the boost request. If you just wanted to go a very basic method of doing that, I'm not recommending it as your chosen method. You choose your chosen method for tuning. But that's one reason why having these tables all normalized is a very, very handy function. Thank you very much.